We don't have time for that. Okay. While we're getting organized, I want you to come up with f of x if f prime of x is 1 over 1 plus x.
This is clearly. This is an M&M.
My fingers.
Okay, f of x. What is it? What's the antiderivative of 1 over x? Yeah, so what's the antiderivative for 1 over? Anything else? Plus c. You remember doing this? Yeah? Okay. So technically, this is called a differential equation. Differential equation. Why is it called a differential equation? Because you have equation with the derivative, differential equation. Okay, so our chapter, or half of a chapter, whatever you want to call it, is all about solving differential equations. Okay, today specifically is going to be separable differential equations. And just to note, on our gold sheet, our homework assignment is coming from the 3-9 line, even though it's 3-10. Okay, so we have the book assignment for tonight. Okay. Okay, so a differential equation. An equation involving a dy dx, so a derivative. Okay, we are actually going to work on separable differential equations where we can group x's together, we can group y's together, and then from there solve for y equals. So the whole point is that we start out with something involving the derivative, and we want to eventually figure out what the original equation is. Okay, it might not be a function, so I don't want to say f of x. It might not pass the vertical line test, but we want to know what our original equation is. Maybe it's x squared plus y squared equals 5 squared. Okay, but we're going from derivative to equation. Okay, now there are all sorts of differential equations, and actually after calculus 3, there's an entire class called differential equations. Okay, in this mini unit, we are going to work with basically one kind of differential equations, when we can actually separate the x with the dx and the y with the dy. Okay, so what you're going to do is you are going to try to get your y, anything with a y over on the side with dy, and we're going to multiply dx over to be with the x so that we can integrate both sides. We're going to integrate one side with respect to y, one side with respect to x. Okay. Then we're going to make it look pretty. Okay. Now, when I ask for a general solution, we're going to have a plus C, just like we did in our warm-up. But if I ask you for a particular solution, then we're going to have to use an initial condition, some sort of coordinate to solve for C. I don't have a daughter. Do you have like the crispy wafer?
Yes. Well, we got like crunchy crisp and then you have like actual wafers like Kit Kat one.
I want the crunchy crisp because it has like both, right? Now I have to search for it.
Let's go.
Okay, the calculus is not the difficult part. We are going to have to work on our algebra. So I need you to make sure that you are dialed in. We'll go slow on some of these. And if you don't understand an algebraic step, you need to ask the question. Okay. All right. So here's an example of a differential equation. Okay. In this one, we have dy dx equals. You could have something that says y prime. If you see y prime, change y prime to dy dx. Okay. All right. So we want the y's to be with the dy and the x's to be with the dx. How do you suppose we could go about doing that in this case? Ooh, we can cross multiply. So we have y squared dy equals 3x squared dx. Yes. Okay, now that we have our variables separated, we are going to integrate both sides. What's the antiderivative of y squared? 1/3 y cubed. Don't write it, but technically we have a plus c. Okay. Over here, our antiderivative would be x cubed plus c. Okay. Now, technically, our plus c's can combine to still be a constant. So what we're going to do is we're going to move this one over to be with the other one, and we're just going to write 1 plus c with the x. Okay. All right, so now we've done the calculus. Now we need to do some algebra to make this look pretty. Okay. If possible, we're going to solve for y. So in order to do that, what are we going to do with this 1/3? Multiply by 3. So we have y cubed equals 3x cubed plus 3 times a constant is still a constant. It's not the same constant, but it's still a constant. Okay. So then y is going to equal the cubed root of 3x cubed plus c. And this right here is the general solution for our differential equation. I could plug any constant in for c, and its dy dx would be 3x squared over y squared. Feel about that.
Just there, but it doesn't really get changed. That's what part of the kind of confusing.
Okay, if I gave you a coordinate, like I know that our equation goes through the point 1, 2, then we can plug in 1 for x, 2 for y, and solve for our c. But kind of like up here in our warm-up, when we know a derivative, we can find its function, but we know that that function could have some constant added at the end, and we're still going to get back to this for our derivative. Are you with me with this plus c?
Yeah.
Okay, so what happens is we have our plus c when we take the antiderivative, but then when we solve for y, it's just not like at the end, it's inside of our equation.
Okay.
Are you with me now? Do another one. This especially is one where we need to be careful with our algebra, okay? So this is not the time to be multitasking. Okay, will it work for us to cross multiply on this one? Ooh, no. Because the 1 over x, excuse me, the 1 plus x in the denominator needs to stay over here. So I can multiply the dx over, but then how do I get the y over? Divide it. Okay, so we're gonna have 1 over y dy equals 1 over 1 plus x dx. Are you okay with how I wrote that? Okay. Well, now we need to integrate. Antiderivative of 1 over 1. Natural log of the absolute value of y. Okay. And then 1 over 1 plus x has an antiderivative of the natural log of the absolute value of 1 plus x plus c. Technically, we do have it on the y side, and then we just combine it over with the x side. So I write that step. Ooh, man, now we have to solve for y. How do we undo a natural log? How do we undo a natural log? I wouldn't say multiply it by e, but e can be the base for both sides. So, hey, what did I say about this example? That's a problem. I said, pay attention. The algebra is important. Okay, so to get rid of a natural log, we can take the e and make this our exponent. Well, if I do it to one side, I have to do it to the other side. Okay, well, how does that help? E to the natural log cancels out and we're left with y. Okay, now, side note. A squared times a cubed equals a to the 5th. I cannot cancel out this E and this natural log because we have this plus C right here. But what we can do is we can rewrite it as E to the natural log of 1 plus X times E to the C. I basically took that exponential property and I used it backwards. Since I have two exponents that are being added together with my base of E, I wrote it as E to the power times E to the power. Okay, well, how is that helpful? First of all, E to the C is a constant, okay? So we can write Y equals C times, well, E to the natural log cancels out. Yay, algebra. Do you have a question about any of the algebra that just occurred? Are you done? Awesome. Why do you guys do this to me? 17.06 pi. How did the C what? So E to the C is a constant.
Oh.
So I'm just gonna write it as a constant.
Oh,
So what, the number that constant equals changes.
Throughout.
We just
Yep.
did this.
Yeah, because otherwise that creates like more algebra for us later. Okay.
That makes sense. It's a constant.
Yep.
Constant actually is-
Okay, so now here is one, Dylan, where we have a differential equation and an initial condition. So in this example, we're going to take our general solution and use the coordinate 4, 3 to find a particular solution. Okay, so first, we're gonna start with just this right here. If I were to get y's with dy and x with dx, hey, we can cross multiply this time, can't we? Now, the negative only stays with one of the variables. I am going to encourage you that any coefficient you have on the right side stays on the right side with the dx. Eventually, we're going to have to solve for y. So the less you have over on the dy side, the better, if possible. So let's write this as y dy equals negative x dx. So then we can integrate both sides to where we have, no, I was just gonna make sure you're writing this down. 1/2 y squared equals negative 1/2 x squared plus c. All right. What's our next move? I heard nothing. Multiply by 2. And remember, 2 times a constant is still a constant. So we'll just, I mean, it's not the same constant, but it's still a constant. So we'll just call it C. Okay. Here is where you have to be so very, very careful. what happens when we square root both sides of an equation? We get plus or minus the square root. So this right here is our general solution. Okay, when you're asked for the general solution, this would be it. And even when we're working towards a particular solution, we first need the general solution. Well, now we know that y of 4 equals 3. Okay, so we're going to come over to this right here. Now, I'm probably not going to pick both the positive and the negative. So we need to decide which one to pick. Why? You're right that it's positive, but there's a better reason than it's easier. Look, our coordinate has a positive y. So our particular solution needs to have a positive y. So we're going to take this and we're going to say y equals the positive square root of negative x squared plus c. So I'm going to plug 3 in for y and 4 in for x. This doesn't look like a 3. Let me fix that. How do I solve for c? Square both sides. Sounds good. I guess I can just write this as 16, huh? Let's see. Okay. So our particular solution is y equals the positive square root of negative x squared plus 25. Or if you write it as 25 minus x squared, nobody's going to be upset about that. What? Okay. Sure. What is this particular solution a graph of? A semicircle. Okay. Technically, our general solution would be 2 semicircles that create a circle, right? And then in particular, this is going to be a semicircle. Okay. Now let's talk about if we had the coordinate y of 3 equals negative 4. In this problem, we would have to choose y equals negative square root of negative x squared plus c. Because our y is negative, we need the negative square root. Okay. So we would put negative 4. And look at this. We have a negative number equals a negative expression. That's probably good. Okay, so I totally chose like the other semicircle. So I can guarantee you this type of problem will come back again. And I do not want it to burn you on next Friday's 50-point test. So we'll practice it again, especially after spring break. Okay, but this is something that you need to watch out for. All right, one more problem. What I would like you to do without me is separate the variables and integrate both sides and stop. Separate both sides, integrate, or separate the variables, integrate both sides, and stop. We cannot cross multiply. Austin, when you separate the variables, what do you have? How about just 1 over x squared? Okay, now when we integrate both sides, when we integrate 1 over y, we get the natural log of y. The right side has nothing to do with the natural log. So if you wrote down the natural log of something, go ahead and erase it. This is the same thing as x to the negative second, which means our antiderivative is negative x to the negative 1 plus. Whoops. That's okay. It's been a couple days since we've had to do an antiderivative like that. Please learn from the mistake that you just made. And remember that there's a power rule. Okay. Okay. So now what are we going to have to do to both sides? E. We're going to exponentiate both sides so that e to the natural log cancels out. And we are left with y equals e to the negative x minus 1 plus c. Okay. Is that how I want you to leave it at? No. Let's remember that if we're adding the exponents, we can rewrite it. Okay. So technically we have y equals c e to the can I write it as negative 1 over x? I'm kind of tired of writing all those negative signs. So there is our general solution. First of all, do you have any questions about the algebra? Okay. So we have this right here. For our particular solution, we are going to take y equals c e to the negative 1 over x, and we are going to plug in 3 for y and 1 for x. So we have 3 equals c e to the negative 1. I love algebra. Just what? Divide by e to the negative 1, right? And 3 divided by e to the negative 1 means c is 3e to the positive 1. right? I can take that negative exponent and bump it up. Okay. So our particular solution, y equals c times e to the negative 1 over x. Well, that doesn't look pretty, does it? Y equals 3. Since we're multiplying, this is like e to the first power times e to the negative 1 over x. We can write this as our particular solution. What do you think? You understand it, but you don't like it? We have a little bit more algebra to do in this chapter, and that's okay. Algebra is okay. We had a nice little break from it, didn't we? Okay, so this is what I want to have happen. I'm gonna get the book assignment projected on the screen, and I want you to try to get 2 problems done before you leave. Okay. While you work on that, I owe a handful of you a Jolly Rancher. My homework heroes. I'll come around. Oh, that's not what I want.
I am. She's not. I am.
What's the first problem? 1. And then the second problem?
3. What?
That's why I was.
Accidentally.
Yeah.